All right, our first example is we're going to be given a sample of 44 from which we observed x equals 32 successes. Remember, n is number of trials, which is the same thing in this instance. That's the same thing as the sample size. And x is the number of successes. And we have in our formulas, we know that we can compute p hat is number of successes divided by number of trials. And then once we have p hat, we can also compute q hat, 1 minus p hat. So I'm going to go ahead and do that computation. That's straightforward. Before we do anything else, we might as well go ahead and find these numbers, which are easy to find, get our partial credit. So we have 32 over 44, and take my handy dandy calculator here. I got my little calculator guy there. Hello there. I'm going to take 32, divide by 44, and I have 0.727. I'm going to round to 3 decimals. 0.727. If you want to round to 2 decimals and use 0.73, that's fine. I'm going to use 3 decimals. And then Q is 1 minus that. So that's 1 minus 0.727. And that's 0.27. Again, I'm going to round to 73. All right? Now, here's the big deal. This is our formula for confidence interval for population proportion. All right? And this is on the formula sheet that you can find at the bottom of the class page on my website. The confidence interval for the population proportion is p hat plus or minus z alpha divided by 2, excuse me, and then the square root of p hat times q hat over n. And that's it. Notice this is z alpha over 2. This is not t alpha over 2. This is used if we're estimating the mean. We're not doing that. The z is what we're going to use when we estimate the proportion. So, particularly on exam day, both of these will be intermixed together. And so you need to keep your wits about you. Bear in mind, when you're computing confidence interval for the mean, it's the t table. Confidence interval for the proportion, use the z table. That should be clear because of the formula. The formula sheet is given. You don't need to memorize any of these formulas. This is the z table, not the t table. Notice we don't need degrees of freedom. And so we're back to the z table, which is the first one we used we use it before we used the t table. So this is the z table. But there's a special, because this formula sheet was so well designed, if you look in the lower left corner of this table, it says confidence interval critical values z alpha over 2. Confidence interval critical values z alpha over 2. You can express this using level of confidence. 90% confidence, the value is 1.645. 95% confidence, 1.96, and so on down. I commit this semester, the only confidence interval values I will ask of you will be one of these. If it's not one of these, I won't ask this of you. Now the text might, and so, but any problems on the textbook, if they ask for something other than this, I will make an adjustment and tell you what it should be. But anything I ask of you will be one of these 4, so you don't need to worry about how to look it up in the body of the larger table. All you need to is to use this smaller table for us for this semester now. Now, so what this table tells you is this. If you're working a 90% confidence interval, 1.645. Now, what does that correspond to? That corresponds to z alpha over 2. That is this number in the formula. Z alpha over 2 is the number given in this table. One of these four numbers for everything we'll do in our course this semester is going to be the Z alpha over 2 number that we'll use in this formula. All right? So, in our problem, let's go back to what we have here. In our problem, we're working a 90% confidence interval. So we're at the 90% confidence level. We need to find, according to this formula, we need to find a value for p hat, Z alpha over 2, p hat, q hat, and n, all of which we have. All right? We have p hat 0.727, q hat 0.273. We have n is equal to 44. All we need is this Z alpha over 2. And since we're doing a 90% confidence interval, we're going to be using this special table. 90% confidence interval, the value we want is 1.645. 1.645 is the value that I want for Z alpha over 2. So for our work, Z alpha over 2, 1.645. We have all the pieces. All we need to do is put them into this formula and do some computation. So let me zoom back out so I can see what I'm doing here. So we need p hat. I'll just rewrite this again so we can see it better. P hat plus or minus Z alpha over 2, square root of p hat, q hat over n. Notice this is the Z table. We do not need degrees of freedom here. So this corresponds to p hat we know to be 0.727 plus or minus Z alpha over 2. We've already computed that. That was, or not, we didn't compute it. The table gave it to us, 1.645. And then that's the square root of, in the numerator we have p hat again, 0.727. Q hat, that's 0.273. All over n, and the square root of the whole thing. And so what's left is mash buttons on the calculator. Again, this is the point estimate. This is the margin of error. Table value, standard error. And so we have 0.727 plus or minus, and now I'm going to get my little machine and do the computation. 1.645 times, I'm going to say that's, and I'm going to use my rounded values, so this is going to be a crude approximation, which for us is sufficient. 0.727 0.727 times 0.273, divide that by, what was my n in this case? N was 44. And then I want the square root of that. And I have 0.067. Again, this is an approximation. Depending upon where you round in your problem, you might get 0.068, 0.065. You might carry out 4 decimals. I'm okay with however you do this. So long as you show me what you're doing, I will be forgiving of your rounding. And then multiply that number times 1.645. So I'm going to clear. I'm going to say 1.645 times 0.067. Again, this has round off error brutally accumulated here, but my number is 0.727 plus or minus, and I have 0.110 or 1102 if you prefer. That is my confidence interval for the population proportion. Now, for our purposes, this is finished. But a way to think of this, remember, this is proportion. A way to think of this is 72.7%. You can think of it as percent, but we should write it as proportion. And then plus or minus, as a percent, this is plus or minus 11%. It's a fairly wide margin of error, and part of the reason for that is we had a small sample size. So if you wish, you may express it this way. For our purposes, this is sufficient.